Assalamu alaikum students. We start the review exercise 2. In this exercise, we recall many concepts related to this chapter. So let's begin with the first question in which we are required to solve few MCQs. In question number 1, we are given multiple choice question and we have to choose the correct answer. Actually, in these, we have to apply the concepts which are discussed in this unit. So let's recall these, and by the solution we get the right answer. In part 1, we are given 27x raised to power minus 1 whole raised to power minus 2 over 3. We have to apply the laws of exponent to find out the right answers of the four options. So let's do by the solution. 27 x raised to power minus 1 whole power minus 2 by 3. What we do in this, we find the prime factors of 27, which are 3 into 3 into 3, and we apply the law of quotient of power with the same base, x raised to power minus 1, so we take it into the denominator, whole power minus 2 by 3. In the next step, law of sum of power we apply it, it becomes 3 raised to power 3 x whole power minus 2 by 3. We apply the law of power fraction, so 3 raised to power 3 multiply minus 2 by 3, x raised to power minus 2 by 3. 3 is cancelled by 3, we have what? 3 raised to power minus 2 and x raised to power minus 2 by 3. X is taken to numerator, so it will become x raised to power 2 by 3 divided by 3 raised to power 2. As we can write x raised to power 2 over 3 as x raised to power 2 multiply 1 by 3, and 3 raised to power 2 as 3 multiply 3. And what we get over here? X square third root divided by 9. Why? Because we know that 1 over 3 is actually help us to find out the index of the root value. So x square becomes the radicand and 1 over 3 will give us the index 3. So it is third root of x square, and 3 3 is a 9. So hence the right option of the first MCQ is third root of x square over 9, and that is A option. Let's do the point number 2, in which we are required to write 7th root of x in exponential form. In this unit we learn how to convert the radical form into exponential form and exponential form into radical form. So let's do it, and let's recall it. 7th root of x. 7th root of x can be written as that 7 is actually index, so that can be written as x raised to power 1 over 7. So that is its exponential form. So which is the right answer? C option is the right answer for it. Let's do the part 3, in which we have to write 4 raised to power 2 over 3 with radical sign, and we have to choose the right answer. So 4 raised to power 2, 4 raised to power 2 by 3 can be written as 4 raised to power 2 multiply 1 by 3, because 2 multiply 1, 2 ones are 2 by 3 is same. So but that provides us index 3, and we can write as third root of 4 raised to power 2, and which is the right answer from part 3, that is third root of 4 square, and that is A option. Let's do the part 4, in which we are required to tell that in third root of 35 the radicand is. We recall the concept of radicand. As we know the basic principle, that is, if we write third root of 35, so then that 3 is index, and that 35 is what? That is radicand. So all the values which are written under root sign, that value is known as radicand. So hence the right answer is C option 35. Now we move to the part 5, in which we are given 25 over 16 raised to power minus 1 over 2, and we have to find the equal values given in these 4 options. So 25 over 16 whole power minus 1 over 2. So 25, its factors are 5 into 5, and factors of 16 are 2 2s are 4, 2s are 8, 2s are 16, whole power minus 1 by 2. 5 raised to power 2 according to law of sum of power, and in denominator 2 raised to power 4 by the same law. We apply law of power fraction. 5 raised to power 2 multiply minus 1 by 2, 2 raised to power 4 multiply minus 1 by 2, 2 1s are 2 2s are 4, 2 1s are 2 1s are, and what we get 5 raised to power minus 1 divided by 4 raised to power minus 1 2s are minus 2, and what we get over here 5 raised to power minus 1 divided by 2 raised to power minus 2. To make these powers positive, we have to apply the law of quotient of power with same base, and 2 raised to power 2 it becomes, and 5 raised to power 1. 2 raised to power 2 means 2 multiply 2, and hence we have the final right answer, that is 4 over 5, and the option is B. Let's do the part 6 of review exercise 2. In this, we are required to tell the conjugate of the 5 plus 4 iota. As we know that the conjugate of the complex number is obtained by changing the sign of imaginary coefficient. So we have 5 plus 4 iota, so it means the conjugate will be 5 minus 4 iota, and the correct option will be 5 minus 4 iota. In part 7, we are required to find out the value of iota 9, and in exercise 2.5, we learn how to find the integral powers of iota. So let's recall iota 9. As it is an odd power, we write as the sum of even and odd. Iota 8 dot iota according to law of sum of power. We can write 8 power as 2 multiply 4, and we apply law of power, iota square whole power 4. We put the value of iota square, that is minus 1. Negative number having even power will become positive, so that will become plus 1, and hence we have the value iota. Hence it means the right option for the part 7 is C. Let's move to part 8. Every real number is one of its kind, mean a positive integer, rational number, negative integer, or a complex number. In the lecture of complex numbers, we learn that every real number is a complex number. So it means the right option is a complex number. But for understanding, we recall the concept, and the concept is natural number. Set of natural number is a subset of set of whole numbers, and set of whole number is subset of set of integers, and every integer is a rational number, and every rational number is a real number, and every set of real number is a subset of set of complex numbers. So that is the idea which we learn. It means every element of set of real number is also an element of set of complex number. So that is what we read over here. Every real number is a complex number. Let's move to the part 9, real part of 2ab into iota plus iota square. This needs a little bit solution. Let's do it. 2ab into iota plus iota square. What we do for this? We multiply, we open the bracket. So 2ab iota plus 2ab iota square. We put the value of iota square, and that is -1. Hence 2ab iota plus minus minus 2ab. We rearrange, we write the real part first, minus 2ab plus 2ab iota, and what we observe that is the real part, mean minus 2ab. So the right option for part 9 is B, that is minus 2ab. We move to the part 10 of this question number 1. Imaginary part of minus iota into 3 iota plus 2. Again, for better understanding, to mark the right answer, we need a little bit solution. So minus iota into 3 iota plus 2. Minus iota into 3 iota, we get minus 3 iota square. Minus plus minus 2 iota. Minus 3, we put the value of iota square, that is -1 minus 2 iota, and we have 3 minus 2 iota. And we know that one is the real part of z, whereas this one is the imaginary part of z. It means -2 is the imaginary part for this. So we mark the right answer for this part 9, and that is option A. Let's do the part 11, in which we are required to tell the closure property of with respect to addition does exist for which set in the given 4 options. We are given 4 different sets, and we have to check that which of the following sets have the closure property with respect to addition. That is the recall of the closure property. This kind of a question is not discussed in the whole unit, but only the MCQ is given. Let's discuss by the solution so you can get the right answer as well as the real understanding and the concept related to the closure property of the sets. One by one, we check all of these sets whether they have closure property with respect to addition or not. So first of all, we take the set having 0 in it. How to check this, what kind of property this set has? We add the same number, 0 plus 0, that is 0, and that belongs to the set. We multiply the same number, 0 multiplies 0, and that is also 0. It means it also, that 0 belongs to this set. It means closure property with respect to addition. Closure property with respect to addition as well as closure property with respect to multiplication does hold for this set. So both properties actually exist in this. Let's take the second option, mean the B, in which we are given 0 minus 1. We check its closure property with respect to addition. How? First of all, we add 0 into 0 and we get 0. We add 0 to the second number, -1, we get -1. We add second number in the first number, we get again -1 by the addition. We add -1 in itself, so we get -2 that does not belong to the given set. So hence we come to the conclusion that closure property with respect to addition does not hold. Closure property with respect to addition does not hold for this set. We check the closure property with respect to multiplication. We multiply 0 by itself. 0 multiply 0 is equal to 0. We multiply 0 to the second number minus 1, that is equal to 0. We multiply minus 1 to the first number 0, that is 0. We multiply minus 1 to itself, and what we get? 1, which does not belong to the given set. 0 minus 1, and it means closure property with respect to multiplication also does not hold for this set. We take the third set, and that is 0, 1. We do the same process which we do in that second part. 0 plus 0, 0 plus 1, 1 plus 0, and 1 plus 1. And what we observe in the result, we get 0, 1, 1, and 2. Again, 0, 1, 1 belongs to the set, but 2 does not belong to the set 0, 1. Whereas 0 multiplies 0, 0 multiply 1, 1 multiply 0, 1 multiply 1. We do the same process which we do in second part. So, and we get the result for multiplication 0, 0, 0, and 1. It means that all of the element, they belong to what? They belong to the set 0, 1. So it means the closure property with respect to multiplication does hold, but the closure property with respect to addition does not hold for this set. So part 4 is to be checked, and in that part we are given a set 1 under root 2 1 over 2. 1 plus 1. We check the closure property with respect to addition. 1 plus 1. The first element deny that the closure property is there. 2 does not belong to the set 1 under root 2 1 over 2. That means 2 is not the element of this set. So hence closure property with respect to addition does not hold for it. If we take only the to check directly whether the property does exist or not, we take under root 2 for multiplication. Under root 2 multiply under root 2, that is equal to 2, which does not belong to the set consisting 1 under root 2 and 1 by 2. It means the closure property with respect to multiplication does not hold for it. As well as in this case, the closure property with respect to addition does not hold for it. Hence we come to the conclusion that the right answer for this point number 11 is option A. As we know that the closure property with respect to addition does exist only in this set for the given question. Now we move to the point number 12, in which we name the property of real numbers used in minus under root 5 over 2 multiply 1 is equal to minus under root 5 over 2. As we know that 1 is such a number which belongs to a set of real numbers which when multiplied to any number, no identity will change. So we observe that when number 1 is multiplied to any number, we get the same number. So hence that is multiplicative identity, and the right answer is multiplicative identity. We move to the point number 13. If x, y, z belongs to R, z is less than 0, then x is less than y. We have to find out which is the right option. So for this purpose, we have to recall the concept, that is, for any three real numbers, z is less than 0. Z is less than 0 stands for minus 1, minus 2, minus 3, and so on, negative integers. So z is less than 0 stands for negative integers. It means when we have, if x, y, z belongs to R, any three real numbers, and we have x is less than y, a negative integer is multiplied to the both sides of that inequality, x, z, y, z, that becomes. So when negative number is multiplied, to less than sign will change into greater than. That is the concept we read in the lecture of properties of inequality of real numbers. So hence the right option is x, z is greater than yz. As that is a little bit difficult, but we recall the concept with the help of an example. We have any inequality like 3 is less than 5, and we have a third number minus 2, which is to be multiplied to the both sides. So when it is multiplied, 3 multiply minus 2, 5 multiply minus 2, we know that 3 multiply minus 2 is minus 6, and 5 multiply minus 2 is minus 10. And we know, according to the concept of real number line, or we know the concept of integers. So ultimately we know that minus 10 is smaller than minus 6. Minus 10 is smaller than minus 6. So minus 6 is greater than minus 10. So we write the symbol over here. It means when we multiply the negative integer to the both sides of inequality, the less than sign will change into greater than. By the example, we come to the conclusion. The right answer for this is xz greater than yz. And that is the application of multiplicative property when negative integer is multiplied. So let's move to the point number 14. If AB belongs to R, then only one of A is equal to B, or A is less than B, or A is greater than B holds is called. Definitely, if you recall the lesson of properties of real numbers, so it is trichotomy property. The right answer is trichotomy property. So A option is the right answer, trichotomy property for this. Let's recall the trichotomy property with the help of example. For this, we have the three relations, that is A is equal to B, A is less than B, A is greater than B. And we have three different sets of values for this. We formulate a table for better understanding. So we have A is equal to 2, B is equal to 3, A is equal to 4, and B is equal to 4, and A is equal to 5, and B is equal to 3. And now we compare. A is equal to 2, B is equal to 3. Simply we observe that the value of A is less than B. It means the right option for this is A is less than B. Whereas in the second part we observe that both the values of A and B are equal, so the right option mark A is equal to B. In the table we observe that A is equal to 5, B is equal to 3. The value of A is greater than B, so we mark the right option over here, and that is A is greater than B. Rest of the option, if we observe whether it is A is equal to B, no. A is greater than B, no. A is less than or greater than B? No. A is equal to B? No. A is less than B? No, for this case. And what we observe, in each of the set of the values, only one option hold, one option is correct. Mean whether it is less than, equal or greater than. Hence that phenomena tell us in the comparison of the two variables, in the comparison of any two quantities, these quantities may be equal, less than or greater than, and that property is named as trichotomy property. Point number 14 got the right answer, and I hope you will get the better understanding as well. So let's move to the point number 15. A non-terminating, non-recurring decimal represents, out of the four options, a natural number, a rational number, an irrational number, a prime number. If we recall the concept, the terminating decimal fraction and non-terminating, if we recall the concept, the terminating decimal fraction and non-terminating recurring decimal fractions are rational numbers, whereas non-terminating and non-recurring decimal fractions are known as irrational number. And we have many examples like pi and the natural log of e. So the right option for this is C option, and that is for the question number 1.